All right, so here's the FRQ from your test. It's a calculator problem. So, oh, Jennifer, you have a question?
Yes. Does everyone have their calculator in radians?
Ah, that's a good question. That reminds me. Good question. Good question. That reminds me of a joke. A joke. Hey, do math majors, do they get a degree or do they get a radian? Very nice. Very nice. All right, so back to the problem. When you read in the FRQ, you really should look for rates. Many times you're given rates. So this one we have Camp Newton holds that much water at time 0. So anytime you see some given information, please think initial condition. You're probably going to use it somewhere along the line. So, looks like we're given 2 equations. This one is a rate, water being pumped into. So we are adding water there. Here is a rate, water's being removed. So we're subtracting water at that rate. So we'll use those in these problems. All right, A, is the amount of water in the tank increasing? Now I know a lot of you will look at amount of water and think I'm going to integrate, I'm going to add up a bunch of water, I'm going to accumulate water. And if you were accumulating water and calculating the amount of accumulation, that would be integration. This says, is the amount of water increasing? And since we're talking increasing, we know we want to check if a rate is positive. That is a derivative being positive. Notice you are given 2 competing rates. Some water's coming in, some water's going out. So your total rate here uses both. The total rate of change of water is W of t minus R of t. The total rate. Some in, some out. So at this problem, what we want to calculate is we want to calculate W at 15 minus R at 15. And we want to check if that's greater than 0 or not. So to prepare, I've taken my graphing calculator. I've already typed in both functions. And what I want to do is I'm going to subtract. So there we go. Second quit. And the easy way to use your calculator is to actually type this in. My first function was W, so here I go. Alpha trace evaluated at 15 minus alpha trace, we need Y2, evaluated at 15. There you go. Negative 121.0900. Make sure you go at least 3 decimal places. This one is not actually asking you the exact rate, it's just wondering, is it increasing or not? Since the rate is negative, what do we have? Increasing or decreasing? Decreasing. Oh, very nice, very nice. So, not increasing because what I've called total rate at t equals 15 is negative. And that's part A. Okay, the second part of this problem. To the nearest whole number, how many gallons? Keyword, what is it? How many is going to tell you the calculus to do. And of course, when you provide your solution, nearest whole number matters. So when you say how many gallons, we don't just want to know the change in water. So when you integrate the total rate, that gives you the change in amount of water on that interval. You want to know exactly how much there is. So we still need to remember this initial condition. So to get the amount of water at t equals 18, you have 1,200 gallons. We are going to calculate the change in water on that time interval, and that will give us our solution. So how do we do it in a calculator? Again, we've already typed in both functions. My total rate is the W of t minus R of t. So here I go. 1,200 plus math 9. We're going 0 to 18. Now, don't always assume this bottom bound is 0. The reason this lower bound is 0 here is because this initial condition occurs at time 0. If the initial condition occurred at any other time, that number would be your lower bound. So, throw it in your calculator. Our total rate, again, was our in function, the water coming in, so that was y1, minus our out function, which was y2. Of course, this is all with respect to x. Enter. Calculate, calculate. Ooh, slow calculator. Ah, there we go. And our solution is... I feel like I've forgotten something. Huh. What have I forgotten?
Nearest whole.
Oh, nearest whole number. That's not the nearest whole number. There we go. There you go.